Okay, welcome to this video, dear learners. Our topic for today is under physical quantities, and this is time. So again, if you are new to this channel, this video, please hit the subscribe button for more notifications. So we'll be making such videos, a complete syllabus in physics. Okay, so time is a physical quantity. Okay, and we say the physical quantity is simply anything measurable on an object. Okay, so time is a physical quantity. Okay, so under time, the SI unit for time, international standard. Okay, the international standard. Okay, international standard unit, that's what SI means. So the international standard unit for time is what? Seconds. Okay, time is measured in seconds. That is the SI unit. Okay, but then we have other units, and these are not the SI units. Okay, so you have other units, e.g. you have minutes. Okay, you have minutes. Okay, we have minutes, we have hours, we have days, months, and we have years, which is the biggest or the largest unit of time. Okay, so they go on. We have centuries, jubilees, and all that. Okay, so all those are units of time, but the international standard unit for time are simply what? Seconds. Okay, it's simply what? Seconds. Okay, so we need to know how to convert from seconds. Okay, from seconds to minutes. We have to know how to convert from seconds to minutes, minutes back to seconds, from minutes to hours, and back. Okay, we have to convert between the units. Okay, we have to know how to convert between units. Okay, because they are not going to simply give you seconds or the time. You have to know how to convert. Okay, you have to know how to convert. So 1 minute is simply equal to 60 seconds. Okay, 1 minute is equal to 60 seconds. Okay, then 1 hour is simply equal to what? 60 minutes. Okay, and 1 day, okay, 1 day is simply equal to 24 hours. Okay, 1 day is equal to what? 24 hours. Okay, so just here, using these three, you are able to convert between these. You are able to convert between these things. Okay, then you can talk of years, months, and so on and so forth, but the most important thing, 1 minute is equal to 60 seconds, 1 hour is equal to what? 60 minutes. Okay, and also 1 day is equal to 24 hours, and that is what? Time. Why? Okay, so for every physical quantity, it is simply measured using an instrument, and so we have instruments that are used to measure time. Okay, so instruments used to measure time. Okay, so instruments used to measure time. So the instruments used to measure time, we have a clock, okay, a watch. Okay, mostly these are rich watches. You have a stopwatch, and something interesting that we call a simple pendulum. And we'll look at the simple pendulum in detail. Okay, we'll look at the simple pendulum in detail. Okay, we'll look at the simple pendulum in detail. Okay, look at this in detail. Okay, so you can use a clock. So those are just the instruments used to measure this time that we're talking about. So now let's look at one specific instrument. This one comes in the exam. Okay, so we have taken an interest in the simple pendulum because it comes in our exam. Okay, so it comes in our exam. So let's look at a simple pendulum. Okay, let's look at what we call a simple pendulum. Okay, so a simple pendulum, the diagram is like this. Okay, so it is simply, it has a string. Okay, it has a string, and at the end there is a bob. Okay, so it's a string and it has a bob, and this bob, it has a center here. Okay, it has a center, right? So this simple pendulum, okay, that's how it is, like this. Okay, that's the pendulum. So it has got this, we call it a bob. Okay, it's called a bob. Okay, this is just a string. Okay, this is just a string. Okay, this one is just a string, and it is hung somewhere. Okay, it could be a wall or something. Okay, so this is the diagram of a simple pendulum. Okay, so now the most important things to note is that we measure the length. Okay, so we are supposed to have the length. Okay, the length. Okay, there are two things, the length and the mass of this bob. Okay, so this bulb has got a certain mass. Okay, we know mass is measured in kgs, length is measured in what? In meters. So the length, when we want to find the length here, it is simply from this part here up to the center of the bulb. Okay, that will give us the length. So from this part here going on up to where? Up to here, where there's the center of the bulb. Okay, so this is our length. Okay, so you might be asked to label the length. Okay, it is simply from the attachment point here up to the center of the bulb. Okay, that gives us the length. Okay, the length should be from the ceiling center. Okay, that's the ceiling. Okay, where the string has been held or suspended. Okay, so this is just a simple diagram of a simple pendulum. Okay, so now this simple pendulum that we are looking at, it can be, let's say we grab this bulb and swing it up to this point. So when we swing the bulb up to this point, the bulb comes here. So we've just swinged it from here where it was, we swing it from here. Okay, so now when we swing it from here, we're going to show our string. Okay, we're going to show our string. Okay, so when we swing it from here, it will go back and swing. Let's say it goes back and swings up to here. Okay, so again we're going to show this like that. Okay, so you find that most of the diagrams, the simple pendulum is shown like this. Okay, but these are just positions. Okay, it's not that you have three bulbs and three strings. These are just positions. Okay, so when we swing it here, we'll call this position A. Okay, now where we started from, this is called the rest position. Okay, this is called the rest position. Before it was swung, this is called the rest position. Okay, it is called the rest position. So before we swung our bulb here, okay, it was here at point, we call this point B. Okay, the rest position. So it swung like that, then it passes through point B, swung here, and we're going to call this point C. Okay, so the bulb will be moving from point A, B, and what? And C. Okay, it will be moving like that. Okay, so now when the bulb, okay, when this bulb has moved, we will start from here. Yeah, so we lift it up to here, then we let go, so it will make its first round up to C, and then it goes back to A. Okay, So that's how the bulb will be swinging. Okay, so from here it goes back here. Okay, so it starts moving like this, reaches here at point C, then it goes back to point A. Okay, so when the bulb moves, okay, when the bulb moves from A, okay, we're saying it moves from A to B, okay, to C, okay, to C, and then back to B and back to A. Okay, it moves like this from A to B to C, back to B and back to A where it started from. So when it moves like this, a complete turn from A, okay, we simply say from A and back to A again. Okay, so from A and back to A again, we call this one complete oscillation. Okay, we call this one complete oscillation. Okay, when the bulb moves from A to B to C and back to B and back to A where it started from, okay, this is called a complete oscillation. Okay, it is called a complete oscillation. Okay, so let's look at some of the terminologies that we have to know on simple pendulum. So number one, we have what we call the period. The period is simply denoted by capital letter T. Okay, the period is simply denoted by the capital letter T. Okay, so period is measured in seconds. It's time. Okay, so the definition say this is the time. This is the time. The time taken. Okay, the time taken for one complete oscillation. Okay, the time taken for one complete oscillation. Now the question is, what is one complete oscillation? One complete oscillation is what we are discussing here. When the bulb moves from A to C and back to A, we call this a complete oscillation. And so the time it takes, okay, or we can say this, we can simplify it and say period, okay, it is also the time taken for the bulb to move from A to B to C and back to A. Okay, that is the other definition, right? Because this definition now is telling you what a complete oscillation is. Right? A complete oscillation is simply the movement of a bulb from A to B to C and back to A. Okay, so the formula for period, okay, the formula for period is denoted by T is simply equal to small letter t over n. Okay, small letter t over n. Okay, so this small letter t is simply what? Time taken. Okay, time taken. Okay, then n simply means number of oscillations, the number of oscillations. Okay, the number of oscillations. Okay, that is what it means. Okay, so there are two things that will affect the period of a pendulum. Okay, there are two things that will affect the period of a pendulum. Okay, let's look at these two things. Okay, there are two things that will affect the period of a pendulum. Okay, so two things that affect that affect the period of a pendulum. So this is important. Two things that will affect the period of the pendulum. Number one, the mass of the bob. The mass of the bob. Number two, the length of the string. Okay, so these two things, they will affect the period of a pendulum. Okay, they will do what? They will affect the period of a pendulum. Okay, they will affect the period of a pendulum. Okay, the other thing that we can add on number 3, also it could also have what we call acceleration due to gravity. Okay, because for this bob to start swinging, okay, for it to swing like this from A to C and back to B, okay, it has to swing. It will depend on the gravity. Okay, it will depend on the gravity. Okay, so these are the 3 things that you need to know, and I will ask you a question on these. The 3 things, okay, that will affect the period of the pendulum. Okay, let's look at an example. In this example, we have example. We're going to say this is example 1. Example 1. So in this example, okay, we have a period, a simple pendulum. Okay, have a simple pendulum shown like this. Okay, so this is point A, this is point B, this is point C. So in this diagram, this period, this pendulum started swinging from A, passed through B, okay, and goes back, and it stops at B. Okay, starts at A, goes to C, and goes back and stops to B. So it doesn't reach back to A. So this is not a complete oscillation. A complete oscillation, it has to reach A. Okay, it has to reach A. So let's look at what the question is saying. Okay, so the question says that it takes, okay, it takes, okay, it takes, okay, it takes 3 seconds to go from A to C back to B. So it took this amount of seconds. Okay, it took 3 seconds. It took 3 seconds. Okay, then the question now says what is the period? Okay, then question B says what is the frequency? Okay, so we have 2 questions. We have 2 questions here. So we are told that this period, this pendulum, it swung from A to B to C and back to B, and the time that it took to move from A to C and back to B, it took 3 seconds. Okay, it took 3 seconds. Okay, it took 3 seconds. Okay, it took 3 seconds. So let's figure out our data, what we have so far. So we're told the time. So 3 seconds is the time, right? So time, which is small letter t, the time taken, it took 3 seconds. Okay. Okay. So from the formula, okay, from the formula, remember the formula, we said the period is simply equal to time taken over number of oscillations. So for us to find the period, we need time taken, which we've been given as 3 seconds. So the other thing we need is the number of what? The number of oscillations, the number of oscillations. So the number of oscillations n, the number of oscillations we're going to say, okay, so it moved, we're going to count the amplitudes, so it moved, okay, sorry, it moved from A to B. From A to B, this is 1. From B to C, this is 2. Then from C to B, this is 3. So it moved 1, 2, 3. So I'm going to say 3 over what? Okay. The total, if it moved here, this would have been number 4. Okay. This would have been number 4. So 3 over 4. Okay. These are the number of oscillations. So 1 like this, 1 complete oscillation. So when it moves from A to B to C and back to B, you're just going to count 1, 2, 3, then over 4. Always it's over 4. If we are told it moved from A to B and to C, would have said, okay, this would have been 1, 2, 2 over 4. Okay, 2 over 4. But in this case, it went 1, 2, 3, so 3 over 4. If it moves 1, we're going to say 1 over 4. If it moves 1, 2, we're going to say 2 over 4. If it moves 1, 2, 3, 3 over 4. That is the number of what? Oscillations. The number of oscillations is 3 over 4. Okay, so let us find the period now. Okay, period is equal to time over n. Okay, time over what? N. So our time is 3 seconds. What is my n? My n is 3 over 4. Okay, so I'm going to write 3 over 4. Okay, so now like this, it will be difficult to solve. Okay, so I'm going to change this to what? I'm going to say 3 seconds divided by, okay, so this symbol converted to divided by 3 over 4. Okay, then I can solve it as a fraction. I'll put this over 1, then it becomes 3 over 1. Okay, so this sign will change to multiplication. These are just fractions. Then the 4 goes up and the 3 comes down. Okay, so then this can go, 3 and 3 can go, 3 into 3, 3 into 3, okay, which is 1, 1. Okay, so 1 by 4, it's 4. Okay, so 4 into 1, this will give us 4. So this means that our period is simply 4 seconds. Okay, our period is simply 4 seconds. Okay, our period is 4 seconds. Okay, let's look at another example. So in this example, example 2, okay, example number 2, okay, example number 2 says it takes 4 seconds to move from A to B to C. Okay, and we have the diagram shown here, the bulb. Okay, so this is A, B, and C. So this one moved like this. Okay, and this is where it ended from. Right? That's why it ended from. Okay, it moved like this. So from A to B to C, and it took 4 seconds. Okay, it took 4 seconds. Okay, it took 4 seconds. Okay, so now the question says find the period. Okay, find the period. Okay, So period, we're going to say period is equal to T over N. Okay, so the time, we're going to say it is 4 seconds from the question. The number of oscillations, it moves 1, 2. Okay, so this is 2 over 4. Always do 2 over 4. In this, we're going to say, okay, this is 4. This sign will change it to this, then we write 2 over 4. Then we put this one over 1. This is going to be 4 multiplied by, this one goes up, 4 over 2. These are just fractions, eh? They're just fractions. So 2 there, 1, okay? 2 into 4, that is 2. 2 by 8, 2 by 4, that is 8. So our period is 8 seconds. Okay, this one, our period was 4 seconds. Okay, so we had another question here. What is the frequency? Okay, what is the frequency? So frequency, okay, frequency generated by F is simply equal to 1 over the period. Okay, 1 over the period. So frequency will be 1 over, our period is 4. Okay, and this one is going to give us 0.25. Okay, when we divide this 0.25, and this will be in heads. Okay, it is in heads. Okay, so I hope you've been able to get some understanding about the simple pendulum. Okay, so we've talked to a lot of things. Okay, just to do a recap, so we're talking about time. So we said time is measured in seconds. Okay, time is measured in seconds, though it has other units like minutes, hours, days, months, and we can use this to convert from one unit to another. 1 minute is equal to 60 seconds, 1 hour is equal to 60 minutes, 1 day is equal to 24 hours. Okay, and we said the instruments used to measure this time, we can use a clock. We do have clocks in our homes that we hang on the wall. You can use a watch, a wristwatch, a stopwatch. This is mostly used in the laboratories. And we have a simple device we call a simple pendulum. And we said this is a simple pendulum, okay? So it has got the length and the bob, okay? And we said we have two things, the length and the mass of the bob, and these will affect the period of this pendulum, right? So we said one complete oscillation is when it moves like this. This is a complete oscillation, right? So then from there we looked at the things that affect the period of the pendulum. These are very important: the mass of the bob, the length of the string, and the acceleration due to gravity. And in our next video we'll discuss how each of these will affect the period of the pendulum.